As the Arctic's icy grip weakens due to rapid climate change, a silent menace emerges from beneath the frozen ground. A phenomenon known as permafrost is no longer permanent. Permafrost is a thick layer of soil, rock, and organic matter that remains frozen throughout the year. Permafrost extends over a quarter of the northern hemisphere and locks in a treasure trove of ancient plant and animal remains that froze before decomposition could set in. Permafrost was believed to be a dormant pool, but global temperatures are on the rise. With the Arctic warming nearly 4 times faster than the rest of the world, this frozen layer faces a perilous threat: thawing. Millions of people live in the permafrost zone, in towns that were built on firm ground. As the ground softens, the infrastructure that Arctic communities rely on becomes increasingly unstable, leading to sinkholes, landslides, and coastal erosion, disturbing the lives of local communities. But it's not just the millions of people who live in a permafrost zone who need to be concerned. It's all of us. The vast amount of carbon stored in the northernmost reaches of our planet is an often overlooked driver of the climate crisis. Arctic permafrost stores almost 1,700 billion tons of carbon, almost double the amount of carbon currently in Earth's atmosphere. When permafrost warms and thaws, it wakes up the microbes in the soil that feast on organic matter. This allows gases like methane and carbon dioxide to escape from the soil into the atmosphere, further exacerbating climate change. The implications of thawing permafrost could be even more widespread, with potential to release bacteria, unknown viruses, and even nuclear waste and radiation. Although permafrost can't be directly measured from space, a lot of different types of satellite data, along with ground measurements and modeling, allow scientists to paint a picture of permafrost. Factors like surface temperature, land cover, and snow parameters can be captured by satellites. These data combined allows us to put together a picture of permafrost ground conditions. Thermal missions can provide information about the changes in the temperature of Earth's surface. Radar images give us valuable information on changes in topography, and information on snow conditions and land cover can be used as a proxy for soil properties. But what about the gases permafrost emits? The Copernicus Sentinel-5P satellite measures methane concentrations on a global scale, but these observations require sufficient sunlight and clear skies. Measuring methane accurately in the polar regions is challenging due to Sentinel-5P's orbit and measurement direction, combined with the persistent presence of clouds in the area. ESA's upcoming Copernicus carbon dioxide monitoring mission will have an improved spatial resolution to better observe methane in the Arctic. This will then be used to deduce carbon emissions from thawing permafrost. Yashka Maya, mission scientist for CO2M, explains how it will do this exactly.
So CO2M compared to Sentinel-5 precursor will have an order of magnitude higher spatial resolution. So this will allow that we can look in between clouds much more easy, and this can then observe methane in the Arctic.
CO2M will also have a dedicated measuring mode for better observations over water, which will be equally beneficial for observing more light over snow-covered regions, like the Arctic.
The other advantage of CO2M will be that we have a special measurement mode or type of measurement where we can look better over the water and over snow-covered regions, which is also important in the Arctic and their surrounding oceans.
But CO2M won't be alone. Other Copernicus expansion missions will enhance current capabilities and provide additional information linked to permafrost. The consequences of permafrost thaw are far-reaching and interconnected, highlighting the urgency of understanding and addressing this phenomenon. Efforts to monitor, adapt, and mitigate these effects are vital as we navigate the complex challenges posed by Earth's thawing permafrost.